So this explosive growth in these devices is going to place enormous pressure on the underlying network, the infrastructure that is going to have to support all of this traffic. We fundamentally believe that Moore's Law, which has driven semiconductor development and innovation for many years, is going to be unable to keep up with the rate of growth of IP traffic. The acceleration in applications, while we continue to need increasingly important security and quality of service, will simply outstrip the capabilities of semiconductors according to Moore's Law. We believe that the world will need embedded solutions to solve this problem. We believe that we will need multi-core processors that deliver performance as well as work within the boundaries of power consumption. We believe that Freescale is leading the way. Several months ago, at the Freescale Technology Forum in the Americas, we announced our new generation of Core IQ multi-core applications processors. We call it Core IQ Advanced Multiprocessing. These represent systems, platforms that will deliver 4 times the performance at half the power consumption of our already industry-leading communications processors. They are built on 28 nanometer technology, and they are built on our 64-bit power architecture. We will be sampling these products in the first quarter of 2012. We believe that the next generation networking challenges will be enormous. The wireless infrastructure will need to continue to support existing technologies such as 2G and 3G, while simultaneously supporting future generations like 4G or LTE. At the same time, however, we need to ensure that the equipment installed to deliver 2G and 3G is not made redundant because the service providers simply can't absorb that cost. And at the same time, we need to be concerned about power consumption. And also, we need to help the service providers lower their operating costs. Early this year, we introduced the Core IQ Converged family of processors. This family of processors, the first in the industry that combine multi-core digital signal processors with our multi-core communications processors. In essence, we are delivering a baseband on a chip. This technology will allow the equipment manufacturers to reduce the form factors of their systems, as well as to utilize the same technology to deliver very small base stations, referred to as femto base stations for the home or small businesses, enterprise-sized base stations, such as pico and femto base stations, as well as the more traditional macro and metro base stations. Today, we are introducing the first of the family of products announced early in the year, the Core IQ Converge 913X family of products. These will be used for pico and femto base stations. They represent the most highly integrated devices to drive these base stations in the marketplace. They have a tremendous range of RF interfaces as well as numerous antennae. They are a perfect complement to the RF transistors that we supply to the marketplace. This heterogeneous network of architectures balances our DSP and our COM processors to deliver the optimal performance. The Core IQ Converge is a scalable architecture, uses the same software across the entire range of base stations that I just discussed. To help us drive the cell site costs, drive them down, we need to be able to enable building out significant numbers of base stations across particularly populous areas. We have the challenge that base stations are large, generally speaking. They consume a lot of power, and many neighborhoods are very anti putting in these base stations. We need innovation in order to change this paradigm. And to help us understand some of the most exciting things that are happening in this industry, I'd like to welcome on stage from Alcatel Lucent, the product line manager for the light radio cube of Alcatel, Jerome Meyer. Please join me, Jerome. All right, welcome and thanks for joining us this morning.
Thank you.
So what do you have to tell the audience about the light radio?
Okay, so the challenges that are facing the mobile service providers, our customers, is that the network data demand is really growing exponentially. We see that by 2015, the mobile data traffic will be increasing by a factor of 30 times. So we cannot really grow the networks with the current state of the art. We need something completely different, and we need this to really scale very efficiently. The issue is that although the data traffic is growing very quickly, the revenues of the carriers are not growing as fast, and even most of the time they are staying flat or growing very slowly. So we really need to enable them to constrain the cost while growing the network. Now the issue also is that as you mentioned, we need to manage 2G, 3G, and now LTE. And even in China, where we have TD-LTE running today. So we need to manage all those technologies very efficiently. And the issue also is that LTE is bringing a lot more frequency bands, meaning that today when we have to add another frequency band, we need to add more modules. And this will not be sustainable. And the issue is that those two main problems are raising is that we cannot really grow the network as much as we would like to, because this is expensive and we cannot cover with this current state of the art, we cannot cover the entire country with this kind of equipment. So we need really to enable the service providers to increase the capacity, increase the coverage of the network, and at the same time lower the total cost of operating this network in terms of electricity consumption, in terms of operating and maintenance. So we need to enable them to do so. So this was the main challenge that we were facing last year when we introduced light radio. Light radio is a novel architecture that is distributing the base stations throughout the network in a much smaller form factor that is smarter and that is more connected. And at the same time, we'll be leveraging the cloud. So we'll have a cloud-like architecture that will be powering this mobile network. And for this, we're actually using Freescale QRIQ converged multi-core product that will enable us really to have something a lot smaller and a lot more efficient. So you can see here, this is what the typical base station on the network looks like today. It's pretty big, it's not very efficient to manage several technologies at the same time. And this is the issue that we're facing when we are upgrading to LTE. Often we have issues in terms of site constraints, in terms of electricity consumptions. And this is not even showing the big antenna panels that you are seeing. I'm sure that most of you have seen the big antennas on top of the mast and the rooftops and so on. So we're introducing a completely new architecture. You can see here, we are shrinking this base station, the RF capabilities of the base station, onto this little cube that can fit in your hand. So it's really a game changer in terms of network architecture. So we're really excited to be partnering with Freescale on the base station on the chip aspects and with HP on the cloud.
What technologies do you intend to support with this light radio for the service providers?
So the light radio cube is a remotely configurable active antenna that can support any technology. So 2G with GSM, 3G with UMTS and LTE, whether it is LTE-APD as we know it in the US, for instance, and TD-LTE as we know it in China. So it's really, really flexible, and it's really going to enable to have complete investment investment protection on the base stations, because once the operator decides to retire 2G, then they can reuse the asset to continue with 4G.
Very impressive. So how did the service providers going to benefit from the use of this technology in their network?
So there are several benefits that the Cube allows. The first one is that in terms of capacity, with this kind of smaller base station and chip, we can have more capacity, so 30% more capacity at the Cube level, because we have beamforming algorithm that we can control in much more smarter way. And it cuts the cost of delivering the data by half, while at the same time we reduce the cost of operating the network. So we cut the electricity consumption, we reduce the operating and maintenance expenses. We can often also reduce the number of sites that are required on those big towers. So we can really have by up to 50% total cost of ownership reduction at the network level. So, and it's very flexible because you can stack several of those cubes together to provide for more coverage or more capacity. For instance, if you stack 8 by 2 cubes like this, you can have a coverage which is equivalent to a 3G macro cell base station today. So we're really doing this to enable service providers to deploy networks in a much more flexible way. It can be installed virtually anywhere, but it's very, very small. So we can have small cells which can be deployed on walls, on street lamps, and so on. And we can also have more traditional base stations to provide coverage by stacking several of those up together. So light radio is really about breaking up the traditional and monolithic RAN architecture. So instead of having a big centralized network where we have big cell sites, we distribute this in a much more efficient way throughout the network to provide capacity where the users are, while at the same time we leverage a cloud-like architecture where we centralize the baseline processing and we centralize all the controlling aspects. So we can have really a more efficient use of the network, and we have a cloud-like network with connected device everywhere on it. So, as you were mentioning before, it's really the era of connected intelligence, and light radio is really a testament to that because our customers are really facing firsthand the massive growth in data traffic. So it's really about enabling them to access all of those devices, all the tablets that we have seen, all the cars that will be connected in a couple of years from now. So it's really about enabling the mobile network to support all of this. And again, with a cloud-like architecture, we can really reduce the capital expenditures by up to 20%, and the operating expenditures, which are really becoming a big problem with the carriers today, by up to 60%. So with light radio, to wrap it up, it's really about delivering greener networks that can be operated a lot more easily, so with the multi-technology aspects, and that can be deployed anywhere. So we really want to have these little cubes everywhere in a much more invisible way. So thanks very much, Rich.
Jerome, thanks very much. We're certainly proud at Freescale to be a part of the Alcatel Lucent development here. You truly are changing the world of wireless infrastructure. Thank you very much.
Thanks.
Let's turn and take a look at the automotive sector, a sector which is also undergoing tremendous electronic change. The automobile, in some senses, is becoming the ultimate smart mobile device. Freescale, as you know, has been a leader in electronics in vehicles since the late 1970s, early 1980s, when we developed the first electronic fuel injection system. We have continued to play a significant role in the evolution of automotive electronics. Vehicles today are becoming as much electrical systems as mechanical systems. The continuous electrification of automobiles is driving continuous energy savings. The dramatic growth in automotive electronics is dealing with some of the truly major trends that are taking place. The automotive industry is the most complex, difficult, demanding industry in electronics. They are insisting that all of their suppliers and themselves deliver zero defects. Their goal is to achieve energy efficiency and continuous safety. They want to get to zero fatalities, zero injuries associated with vehicles, and that requires a partnership between the component suppliers, partners like Freescale, and the system companies. Interestingly, as the growing middle classes in emerging markets such as China increase their desire for mobility, they want vehicles. Most of these first-time buyers can only afford what we will refer to as value models. These value models, unfortunately, have minimal safety and minimal conveniences. However, the automotive industry here in China is continuously increasing their investments. They are trying at the same time to enhance the consumer's experience. They're trying to provide differentiation, but they're trying to continuously increase the safety. Several months ago, Freescale introduced our S12 Magna V microcontroller family. This is based upon advanced technologies that allow us to combine digital programmability, high precision analog, as well as a portfolio of different memory sizes. These solutions can be delivered either in a single die or dual die form. These solutions replace the current market, which requires about 4 chips to deliver the same capabilities. Today, based upon that technology, we are announcing a new Antipinch window lift reference design. We have done this in conjunction with Tongji University here in China. This reference design is based upon our S12 Magna V family of microcontrollers. This will allow system developers to connect very high voltage signals directly to the microcontroller. This capability is integrated with the microcontroller. It will eliminate a number of other functions. This simplifies and reduces the bill of material, reduces the board size, increases the overall quality, thus cutting costs and design complexity. This reference design is going to enable manufacturers to implement these safety capabilities in their cars much more quickly, thus enhancing the safety and convenience of that vehicle. We're also announcing today an enhancement in our sensor family. We have, as many of you know, a tower system which enables design engineers to rapidly prototype and develop systems based upon Freescale technology. Today, we are announcing the implementation of modules on the tower system for our sensor technologies. This will allow the development much more rapidly of systems that will support such things as airbags, electronic stability control, electronic parking brakes, as well as engine control. As the leading supplier, independent supplier of automotive MEMS sensors, we're very excited and very committed to continuing to develop advanced and very affordable platforms for the automotive systems. Last year, at about this time, we introduced our Coriva microcontroller family. This family, advanced technologies, 55 nanometer, 90 nanometer, 55 nanometer technologies, was developed to deliver powerful and versatile microcontroller solutions for automotive applications. It's based upon our power architecture, and it is designed to increase performance, safety, and energy efficiency. We're very excited that Chery Automobile, a major player here in the Chinese market, has selected the Coriva for their next generation engine control modules to deliver increased fuel efficiency. We're also working on other ways to provide efficiency. We believe that by replacing mechanical and hydraulic systems, we can actually improve fuel efficiency in vehicles by up to 3%. These systems can reduce the weight in the vehicle, adding intelligence and reducing the consumption of fuel. We're also dedicated to other innovations in the semiconductor industry that are going to help the automotive industry. We're improving vehicle safety, we're reducing emissions, and we're improving power efficiency and performance. And we look forward to continuing to work with our partners here in China as they deliver next generation automotive solutions based upon Freescale technology. Let's look at the industrial segment. Energy management is becoming a consideration in virtually every system that is being developed around the world today. The decisions about the design must take into account power consumption and strive for power efficiency. It is one of the major challenges that every design engineer in the world faces. It is estimated that motors, electric motors today, consume about 45% of the world's electrical energy. Simply huge. We believe at Freescale that by using more efficient motors, we can cut that energy consumption by about 25% over the next several years. We have introduced recently a new generation of digital signal controllers to basically help in this area. These digital signal controllers provide much more precise digital control for motors, electric motors, as well as power supplies. These new DSCs provide the fastest signal processing in the microcontroller industry. They are 32-bit cores with a fair amount of on-chip peripherals that eliminate a certain amount of the analog signal processing, replace it with digital signal control, thus reducing the power consumption of these devices. A much smarter way to manage energy use. Data network centers are exploding. Service companies like Baidu, as well as companies for their own personal utilization, are creating larger and larger data centers. The era of connectivity is driving this demand, and it will continue to expand. We believe that data centers today consume about 2% of the electricity, of the global electricity. We think that this, by 2015, will double and continue at that rate into the future. That is really not sustainable. We are working with the developers of the systems for these data centers to reduce the power consumption, to generate less heat, to reduce the energy needed in these centers purely for cooling, to reduce both the board size and the system size. We believe this is a fundamental development that is essential to the continued expansion of the internet. Smart grid is a subject of great importance to all of us around the world. We believe that over the next 20 years, that the implementation of smart grid technologies could achieve $2 trillion in benefits. This is by implementing tremendous intelligence in the network, in the home, in the factory, in office buildings, and connected to the power grid around each of our cities and our nations. We're working with industry leaders to deliver smart meters in the network as well as smart meters in the home to basically find new and innovative ways to conserve electricity. We're developing smart and connected appliances. As you might know, Freescale is the leader in the development and the provision of microcontrollers for the appliance industry worldwide, here in China and in Asia, as well as in North America and Europe. Washing machines, just as an example, are using today 2 or 3 microcontrollers to be much more sophisticated than they were in the past. The water savings from a highly sophisticated modern washing machine can be so significant that you can actually pay for the purchase of another system like a dryer based upon the savings that you can get in water consumption with your washing machine. So we believe that the application of smart technology to appliances in the home, connected with smart meters in the home, connected to the smart meters in the infrastructure, will dramatically change the consumption of electricity, which, as we all know, is critical to our future. Today, we're announcing at the FTF here in China our next generation of 8-bit microcontrollers that will drive much of this evolution. These are built upon our traditional SO8 core. However, they're developed for this noisy, very difficult type harsh environment, like washing machines, noisy environments, and so forth. And we believe that these capabilities are going to help to dramatically drive entry-level MCUs into these devices, low-cost systems that are needed to begin to change the dynamic of energy consumption in these appliances. Let's look at the medical segment for a moment. The development of our societies is causing more and more demands placed on the medical industry. As a result, industry in most nations is turning from simply treating patients after an illness has occurred to trying to avoid such issues in the first place. We're worried about such chronic diseases as hypertension, cardiac failure, diabetes, and cancer. The medical industry here in China, as well as all around the world, is moving from what is very high-cost treatment of patients to prevention. We believe semiconductor technology is playing and will continue to play a very significant role in medical monitoring, diagnosing diseases and problems, therapy, and imaging. In this era of connected intelligence, smart medical devices are beginning to converge in many respects with smart mobile devices that we talked about earlier today. They share a common set of requirements. They need to be small, they need to be portable, they need to be simple to use, and they need to be connected. Smart sensors, together with microcontrollers and apps processors, will assist in diagnosis as well as treatment. To share some of the latest developments that Freescale is involved in, I'd like to bring out on stage our global healthcare segment leader, Stephen Dean. Stephen, please. Stephen, welcome and thanks very much. How are we doing in the medical space?
We're doing quite well, thanks. You know, in the medical field, our embedded technologies are meeting some really pressing needs. But what's more exciting is it's positioning Freescale to play an even bigger part. The world population is continuing to grow, and the issue is that the supply of doctors, nurses, and caregivers are simply not keeping pace. In addition to that, cost of medical equipment, facilities, and other resources continues to climb. So if we continue the trend, the cost will simply overwhelm our systems. In the next decade, the good news is we're all going to be witness to the greatest transformation in history in healthcare, and that will be where our respective cultures shift from focusing on life-treating symptoms, life-critical symptoms, to actually preventing those in the first place. Critical care is the most expensive part of the care. Prevention is the key. Human nature is actually the obstacle.
So what do you think, what do you have to show us today that we're working on?
Well, let's step over here. What we have is a representation of an integrated solution that Freescale has been developing with several of our key partners in healthcare technology. You can take this system, wake up in the morning, and review your biometric data that might have been taken while you were asleep in bed at night. Or you can take these systems and actually use the next generation of personal medical devices wirelessly connected in the comfort of your own home. So first, what I'd like to show you is the Home Health Hub reference design, which is actually a product of an i.MX28 based multi-core processor and the Saber 2 tablet. With that, it integrates a number of sensors, wirelessly connects those to personal medical devices, and automatically updates your personal medical record, which can be reviewed by your caregiver. Taking your blood pressure, for example, Rich, is as easy as placing the cuff on and pressing a button. And as you can see from the sample interface, it takes the reading and transmits that to the Home Health Hub straight away.
It appears to be pretty simple. Is it automated, Steve?
Yes, sir. It's fully automated. The readings are passed to the healthcare provider, yet in another location, and our partners at UI-Centric have actually made the interface very slick and easy to read, where any readings that might be out of range is easy to tell. Let's assume for a second that I have diabetes. Diabetes affects 10% of the world's population. And China and India actually make up 40% of that population. Diabetics need to check their blood glucose levels multiple times a day. And a smart glucose meter like this actually takes some of that inconvenience away. So I can take my normal reading like I've done with my blood pressure, and then, like the blood pressure, it transmits it straight away to the Home Health Hub.
Boy, that looks like we got a problem here. Is that true?
It is true. But the good news is it's transmitted in real time for situations just like this. My doctor, which is in a remote location, takes a look at this information and can actually communicate with me in real time. The interface, the interactive element in this demonstration actually brings us to the final element, and that would be our Vive Robot coming to you here, brought to you by our friends from Vigo Communications. So this is the Vive Robot. It uses two i.MX processors and a multi-touch user interface. Hello, Dr. Jose.
How are you feeling today?
You know, I'm feeling okay, but that blood glucose reading didn't look quite right.
Yeah, your glucose levels is a little bit out of range, but the good news is that I've been looking through your other metrics and everything seems fine. So did you have anything to eat last night?
You got me, Doc. I had a piece of cake before I went to bed.
Well, a little piece of cake once in a while isn't going to kill you, but a dose of insulin right now, it might.
Really? Why?
Well, you're dealing with a dawn effect, which is basically produced by the hormones released to your bloodstream during night. So you shouldn't worry, but if you have taken an insulin dose right now, you might have lost consciousness and gone into coma.
Oh, wow. Well, I'm glad I didn't take them.
Yeah, me too. So just take a regular breakfast, do your daily exercise, and be sure to take your measurements again in your daily routine basis.
Okay. Well, that sounds good, Doctor. Thank you.
Thank you. Bye-bye.
Yep. Bye-bye. Now, if I'd only program this thing to bring me breakfast, it'd be good.
That's a really good solution, Stephen.
Well, thanks. Studies show that remote monitoring of chronic conditions can actually reduce office visits by up to 65%. They can reduce the average hospital stay by 6 days. But really, most importantly, it can actually reduce mortality rates from 35 to 56%.
Pretty incredible. Actually, with this technology, we're using connected intelligence actually to save lives.
Exactly. That's what we do.
Great. Thanks so much, Stephen. Appreciate it. Have a great day.
Thanks
for joining us.
Thanks. Appreciate it.
Well, as we wrap up, I hope that you've enjoyed and learned from the demonstrations and the presentations that we've had here this morning. This technology forum is about powering innovation, and we at Freescale are trying to do that in conjunction with you. We are trying to help you make your technology connected, make it healthy, make it safe, make it more efficient, make it smarter, and we certainly hope that you'll make your systems with Freescale. I want to thank you very much. We have a great event for the rest of today and tomorrow. I want to thank you for joining us this morning and for the next several days. Anything we can do to make this event and your time here with us more productive, please make sure you let any of my colleagues know. Thank you very much. Enjoy the rest of the 2011 Freescale Technology Forum. Have a wonderful day.